Hello, I am Jaekyun, developing line shopping at Line Commerce. For 20 minutes, I will tell you about the requirements for line shopping service and how we met the requirements. Today, I will share my experience of selecting the tool for implementation, and to those of you developing similar services, I hope I can give you a hint. First, introduction to line shopping and tell the service requirements. Next, changes in data processing method to meet the requirements. And introduce platform for scalability and what we have achieved. Line shopping collects online shopping products in one place. And we categorize and group them based on a certain criteria. And we provide information and the means to customers for purchasing products. Japan's Kakaku.com and Korea's Naver Shopping are similar. Users of line shopping want to search for product information scattered in various e-commerce sites. They want to compare prices and which site has the product in stock and what kind of benefits they have when purchasing the products. But exactly syncing up the product data from e-commerce sites to line shopping is very difficult to implement. Sometimes e-commerce sites cannot make quick changes in the data, and the main problem is that line shopping has to aggregate all products from other e-commerce sites into one. So we need to process a vast amount of data. However, if this process is slow, users will see a data from the past, not the present, so we will lose our competitiveness as information provider. Thus, our goal was quickly processing a lot of product data. One product has over 70 attributes, and we can get information of about 450 million products from sellers. But the market is growing, so it is expected to reach 1 billion. Then, how can we process data fast so that we can update online shopping DB? There are two ways in processing data. First is batch processing. It's suitable for large data, but it takes time to gather data. So it's more suitable for statistics than real time. On the other hand, stream processing doesn't require waiting time, so it is suitable when fast response is needed. The main process of line shopping, which is receiving products, is more suitable for stream processing because we have to quickly deliver products information to users. Of course, sometimes it requires batch processing, so we are still using this for some parts. We mix the two appropriately. The point is that you have to choose the method based on the requirements. Now, let's look at a quick and easy way for stream processing. We have chosen Kafka and Kafka Connect. Kafka Connect sends data from a storage system to Kafka in a quick and reliable manner. Also, it can send data from Kafka to other data storage system. For instance, from MongoDB to Kafka and to Kafka to Elasticsearch. So let's take a closer look into the process of Kafka Connect. First, you need to understand what's OP log of MongoDB. So MongoDB and MySQL are in sharding structure or master-slave structure to record log at data level to sync data. Because it is data level log, not query level, even when multiple roles are changed through one query, it creates each change log. This characteristic helps capture DBMS changes as they are delivering them to Kafka topics. And Kafka Connect tells this and produces it to Kafka's topic. So connectors that play this role are called source connectors. You can now consume topics with change messages and save them to other systems such as Elasticsearch or HBASE. These connectors are called sync connectors. The source connector puts various information in the message and sends it to Kafka. Unfortunately, there's no standard for messaging, and their content depends on the type of the DBMS or where the connector is provided. The screen you see right now is a sample of the source connector message provided by Devism. In this message, it includes information about the specifics of the data that has changed, or whether the type of change is create, update, or delete. These messages can be very useful in addition to synchronizing to other storage systems. This is because it has the same order as DBMS data. The traditional method of detecting data changes and sending them to the message queue is to store data in the DBMS and publish it to the message queue at the same time. Unfortunately, this configuration does not guarantee the alignment of the data, and it can be processed in a transaction, but it requires a complicated process, so it can have lowered performance. But if you use Kafka connector using uplog, this transaction processing is not required, so data flows in only one direction that is accurately synchronized with DBMS. I mentioned this before. If there's only one query actually performed with multiple data changes, it becomes a problem. Using traditional method, after the query is executed, the changed content must be read back and sent to the message queue, which is not a simple problem. And in OP log or bin log, even if multiple data are changed as above, the message is generated for each. Kafka's CDC topic is created using these two characteristics, and it's being used as the center of data pipelining. And these data are stored in other systems and are also used in separate stream applications. Now, let me explain the product receiving process, which is the core part of the line shopping and data pipelining. First, this is the process of receiving the product information sent by the seller. This is the process of determining whether it is a new product or a changed product or a target to deleting by comparing it with the previously received product information. In this process, data that has changed is saved in MongoDB. MongoDB changes are immediately transmitted to Kafka via Kafka Connect, and stream applications that consume Kafka topics work by determining whether they need to be handled or not based on CDC data. For instance, an application in charge of image processing consumes a CDC topic to only detect if the image URL is changed. And when a change is detected, the image is immediately uploaded to storage and the results are updated back to MongoDB. And data not of interest are skipped. The data updated with MongoDB will be transferred to CDC data again through Kafka Connect. Stream applications linked to external systems are handled in the same way. And in the figure, you will see only the main ones, but there are about a dozen of these stream applications currently running at the same time. And each is written as an independent application, and when there's a change of data that needs to be processed, you can simply add a stream application in the structure. Product data is quickly processed in parallel through this cycle. If you have enough system resources, you will be able to process near real time. Then what system should we use to increase the amount of data processed with the injected resources and run a reliable service, even in case of a system failure? There are two main ways to improve the processing power of the server. One is scale up. It's improving through expansion of CPU or memory. Of course, there is a limitation in performance improvement, and the increase in performance versus cost is not uniform. On the other hand, scale out is suitable for processing large amount of data, and the increase in performance is uniform as the cost increases. Currently, the e-commerce market is growing exponentially, and the number of products in line shopping in January 2019 was 8 million, and it's now at 450 million. Considering this trend, in order to handle the increasing number of products and data processing, scale out is more suitable than scale up. Among line shopping systems, platforms that need scale out are Kafka, MongoDB, and Elasticsearch, which are the mainstreams of data. But fortunately, they support scale out on their own, and they also have fault-tolerant and self-healing systems. Currently, we operate 9 Kafka brokers and 10 Mongo shards. And if you need a storage space or processing power, you can simply increase by adding broker or shard. In fact, in the beginning, we needed to add the shard from 7 to 10, and we were able to do a stable expansion even when we had to do it online. And there are several options for MongoDB's shard expansion, and it is also possible to expand the facility by avoiding the peak time of usage. And Kafka can also be expanded online. Partitions are automatically rebalanced in the expanded broker, and data duplication or loss does not occur. A system that self-supports self-scaling like this doesn't have a big problem. However, the parts that need additional scaling are Stream Application, RESTful API, and front-end web server, and we chose Kubernetes for this. Kubernetes is a tool that supports automatic deployment and scaling of container-based applications. By using Docker, you can efficiently distribute resources where needed by supporting auto-scaling, regardless of the environment. You no longer have to put effort such as matching the OS version and unifying the environment to install the application, and you can easily implement functions like traffic control and distribution pipelines through third-party tools. And you can also use Helm chart to automate the installation and configuration of applications. We don't need to have a long explanation about the power of Kubernetes. We are actively using Kubernetes for its goods. As a result, we were able to automate installation and distribution, and we were able to have a system that can respond quickly when a situation that requires more resources due to increased product data. This is the area where Kubernetes is applied, and now Line Shopping has a platform that can handle increasing product information and fast processing. And we can now use our resources more efficiently. So this is an example. Line shopping products often change in the early morning hours. It's because early morning is the time when the seller system that creates and sends the product information is free. In this case, most sellers send the entire product. However, in the early morning hours, access to management tools or the front end rarely occurs. So in this situation, if system resources are fixedly allocated to each area, some will get wasted. Kubernetes collects various metrics within a cluster, and you can also collect additional metrics using third-party tools like Burrows. So using these metrics, you can automatically determine your application's resource requirement and configure to auto-scale. Just like this, resources are automatically allocated as needed, and it can be used very efficiently. So as a result, Line Shopping platform achieved first, event-based data processing, second, scalability, and third, resource efficiency and scalability. And to facilitate further development and deployment, the coupling between each application was removed and MSA structure was established. Line Shopping uses Kafka, MongoDB, and Elasticsearch, plus MySQL and HBASE. We use MongoDB as the main storage system, but it has a disadvantage of weak transactions. So when we need sophisticated modeling and transactions, but with a smaller number of data, we still use MySQL. On the other hand, if there is no need for transactions between multiple tables, but if it requires scaling due to a large number of data, we use MongoDB. And for joining MySQL and MongoDB, we use application. The application reads the data from both sides and it combines it. You can also use Kafka Streams or KSQL. First, changed data from MongoDB and MySQL are transmitted to each CDC topic using Kafka Connect. And Kafka Streams join two topics in real time. Now, MongoDB and MySQL's joined data are stored in another storage system using Kafka Sync Connector, or it can be processed real-time by writing Kafka Consumer. Just like this, if you use the right platform and tools, you can respond to various requirements. Lastly, I will introduce how HBASE is used in line shopping. HBASE is a stable and a proven system that is easy and fast to connect with Hadoop, and it is also scalable. And another feature is that it supports column-level storage and versioning. And it only records changed columns, so the storage space can be used efficiently. It is important to know when product information was changed and by whom and by what value. Depending on the side who made the change, disputes may happen with sellers, and due to incorrect operation or errors in application, data may get changed. But MySQL and MongoDB always store the last data, so in this case, HBASE is a good choice. By using the feature of HBASE that supports column-level versioning, you can search the history of changes. So in other words, like in this screen, you can check the change of the product name, and it can be used as a good tool for tracking data. And also there's a snapshot function in HBASE to check the latest information for each column, and you can extract that and link this with Hadoop system. And you can do big data processing, such as data extraction and statistics. So far, I've talked about how we process data in real time and how we implemented a reliable and scalable service using Kubernetes. Line shopping system will be applied to Taiwan following Japan. It will grow into a global platform. So we kindly ask for your interest and advice, and this is the end of my presentation. Lastly, I'd like to express my gratitude to Line Infra team for helping me out. Thank you.